Hello, calculus fans. We've introduced the idea of a limit, or at least we did so heuristically. We did this when we were talking about the slope of a tangent line. And we also talked about the instantaneous velocity of a moving object. So for instance, let's take the function f of x equals x squared minus 4x plus 5. And let's look at its behavior near x equals 3, but not equal to 3. Now this is the key idea in the concept of a limit. We're going to investigate the limit of a function at some point, but we don't care what happens at that point. Now let's plug in a few values of x into the function, keeping in mind that we're not going to plug in x equals 3. Okay, so here we've got a table of values. I'll just show you how we got one of these values. So we'll do an example to see how we got these numbers here. All right, so to see how we're getting the numbers in the table, let's take x equals 2.999, and we're going to plug that into the function. So what we'll get is f of 2.999 is, we plug it into the function, we work all that out, we get 1.998001. If you go back and look at the table, what we can see is that f of x is getting close to 2 when x is getting close to 3. In fact, what we can do is we can make the values of f of x to be as close as we like to 2 by taking x to be sufficiently close to 3. What we're going to say is that the limit of the function f of x equals x squared minus 4x plus 5 as x approaches 3 is equal to 2. And our notation is this. The limit as x approaches 3 of x squared minus 4x plus 5 is equal to 2. Now let's look at the picture. The values of x are getting close to 3. The y values on the curve are getting close to 2. All right, so here's the picture, and you should be able to see that as you go along the curve, when the x values are getting close to 3, the y values are getting close to 2. I don't care really what happens right at this point. I care what happens as we get close. Getting close is the only thing that matters. What happens at 3 is actually irrelevant. Okay, that's all for now.